Hello and welcome to NARC Live on Wednesday the 7th of December 2022. Coming to you live from Norfolk on the east coast of England with Tammy M0TC.
Hello.
And me, David G7URP. Good to see you. On tonight's show, Rob AD0IU brings us a talk on space weather. Let's face it, space has got to be warmer than here right now. We've got details of our centenary special events station, which was run by NARC, and it was a great success. And we find out what on earth this is. Now, I've got to reveal we've only had 2 entries for this. So if you think you know what that is, it's a bit of an unusual one. It is a tool, that's all I can really tell you as a clue. Then you've still got time to tell us. Just put it onto BATC or Facebook and we'll read it out in a moment. But first, details of that Transatlantic Test Centenary Special Events Station. It is the centenary of that transatlantic contact. And over the first 2 days of December, the G6ZZ call sign was activated by 9 NARC members from G0DWV station, who made a total of 1,553 QSOs on all HF bands and modes. The NARC operators were Mark G0TMT, Malcolm G3PDH, Steve G0KYA, Phil G4LPP, Sunny M0SYW, Stuart G4AFF, Andy M0NKR, and Chris G0DWV. And Gordon G3PXT also was involved by running his station on FT8 on bands not operated by the others. We were able to run 2 high power stations, which resulted in some fantastic pile-ups, rag-chew sessions, slow times, strange propagation, and extraordinarily good conditions at times. As Chris says, hearing your own echo as the signal went round the world happened on several occasions. Being called by VK Australia and ZL New Zealand at 5 and 9 plus 30 with no one else on the band, and also hearing echoes that made it impossible to understand the caller's voice, and CW was something else. Also, not knowing which way to beam, as paths long and short at the same time were equally good. Then suddenly changing to EU callers and another spotlight part of the world. Without dissecting the log we made, we worked all continents easily, worked most of the US states, but most of all, we had fun. We were active a good part of the 46 hours we hosted the call sign, thanks to the help from NARC members for making it a fun couple of days. Cycle 25 is looking like it could be very special after all the negative press, and we've waited a long time for that, haven't we, as well. If you fancy activating the call sign for a little while, I'd highly recommend it. When spotted, and you will be, it's great to be called and work a few at whatever pace you like. All the info on how to get involved is on the QRZ page for G6ZZ. Be brave and give it a try. Everyone's welcome, and the more the merrier. And from the club, special thanks to Chris G0DWV for organising and hosting this station for NARC at his QTH as well. Looks like fun. They look like, what are they? Cheese and onion something or other? What's it? Do you reckon?
Cheesy Watsits.
Yeah, they look like that. Oh, makes me feel hungry. We're going to have some meal when we get home, aren't we? Anyway, more news for you. And what is matter most, or what matters most, maybe? James M0ZAH from Teamwave sent us this brief message. You may have seen something also on the newsletter and on the website. Mattermost is a chat tool that acts like a forum or instant messenger. Users sign up for an account and then have access to all the public rooms to chat and share ideas. We create a lot of custom plugins, and these are a few examples, James says. A UK repeater lookup, Mastodon post utility, and a packet network link where users can post to GB7 MSX, which then transmits the message over the air. And there's lots more to come, he says. It's a modern, easy way to keep in touch when not on a radio. And everything they do is open source, so users can audit, adapt, submit code changes to the system. More details on the login of how to get into Mattermost on the NARC newsletter and also on the website. It is on the newsletter that went out today as well. Now, this is one of my favourite bits of the program, because it says train news from Bob G6PWS. It's not from me. He said, I was just going over a railway bridge at Brookman's Park near Hatfield when a loud whistle got my attention. He really had very little time to get this picture as it screamed through. But he found out it was the LMS Duchess of Sunderland, doing a tour from King's Lynn to King's Cross and return. He said it was wonderful watching the reactions of people waiting around the platforms for and getting off the normal trains when this blast from the past comes to them unexpectedly, hissing and panting in and out of the darkness. Wow, that is wonderful, isn't it? It's just from hearing the whistle. Also, he said, Bob sent us a couple of other pictures. These are views from their local Heartwood forest.
That's stunning, isn't it?
There has been some stunning skies lately, haven't there?
Mm.
Absolutely beautiful. This cold weather can bring some really crispy. Look at that. That's an evocative, sort of really cool, damp winter evening. Thank you. Thank you very much, Bob, for sending us that. Peter M0VRA has sent us a message saying, are you going to be up at 5 a.m. tomorrow? I don't know. Anyway, he reminds us that there's a moon occults Mars when the full moon effectively eclipses Mars tomorrow morning, if it's clear, and I reckon it's going to be clear looking out there tonight, at 5 a.m. Tammy looks like she's just setting an alarm.
I am about to.
Well, you better be quiet. Get out of bed quietly, please. Dear me. Anyway, or as we are married, by the way, just in case you just tuned in and thought that was a bit of a random thing to say. Or as the Weather Network puts it, the full cold moon photobombs Mars, which I love that. When I was looking it up to try and find a picture, I love that way they described it there. Anyway, that's 5 a.m. tomorrow. Set your watches quietly.
I have just set my alarm for 4:50.
Are you serious?
I have just done it.
Right, okay. Better not say any more about our domestic arrangements. Anyway, finally, this is an illuminating piece. Kevin M0UJD and Becky M7BE went with their family to Sandringham a few days ago. Sandringham? I hear you say honours, maybe, things like that. No, it's not to see His Royal Highness, but to see Luminate, an incredible Christmas light show. And this is the video that Kevin did for us. Wow, that was...
As Finn put it, wow.
He said wow, didn't he? He's only
really.
2, bless him. Yeah, that was wonderful. Thank you very much for doing that video, Kevin. It really is an amazing light display. And all I can say is to James M0UKS, well, this year Sandringham, next year your drive maybe, never know. Anyway, thanks very much for sending that video, Kevin, and for all of you sending your news and details. Don't forget to keep us in touch with what you're doing, even over this Christmas period, because we'll certainly try and use them on a future show. radio@dcpmicro.com, that's the email address to send them to. Now, it wouldn't be Christmas and it wouldn't be NARC Live without Little People, Tammy.
Yep, here's Little People this week. Have you ever wondered how the trash gets emptied on your computer?
No. Oh, yes, I mean, I have. No. Oh, Is that how it's done?
The bin men come along at night and empty it.
Oh, I love it. That is good. Is that really what happens?
Yeah, didn't you know?
I thought it was sort of virtual and software
No,
and stuff. Oh,
no.
okay.
It's like Andy's toys, you know?
Oh, yes. Yeah. Toy Story. Okay, that is really good. As always, Tammy chooses a picture from this website, miniature-calendar.com. They are really ingenious. A Japanese website, and they always put a different picture on every day. Thank you very much for sharing that, Tammy. That is really good, emptying the bin. That's just such good imagination, isn't it? Really good. Thank you very much indeed. So as I said, keep in touch with what you're doing. Let us know and send your pictures, and then whether they're radio related or not, we'll be very happy to share them to keep the club together, keep us all connected and finding out what each other are doing. Now it's time for that competition reveal. What on earth is this? Now, I don't know if anybody's entered.
There was one on there, I think, which was Mike, I believe.
There's one entry, okay. Someone put giant what's-its. I don't think that was a comment about Kevin, was it?
No, that was the crisps.
Oh, that was the crisps. Oh, yes. Okay, sorry about that. Okay, oh, right, okay, so I'll read Mike's in a moment. So we have had a couple of entries. Firstly, Bob G6PWS says it looks like a coax wire stripper.
Bruce G4KZT said, I think it's a watch repairer. No, he doesn't say that. He said, a watch repairer friend of mine many years ago had something like this. I thought it was some kind of wire cutter, but he told me it was to remove the balance wheel pin. I think he called it a staff. I'm sure it could also be pressed into service as a tool for maintaining for the maintenance of a sewing machine.
A sewing machine? No, Bruce, no, we don't do those things anymore. Okay, and Mike, G8EY, says, I think it's a tool for cutting the barbed nylon ties used in multi-packs of socks that an annoying relative sends each year. I can't think what he means. So what is it anyway? There we've got those three entries. Anybody else? Just want to make sure nobody else had entered at all. It's obviously Foxdew. The answer is this. It is a balance staff roller removing tool. So well done to Bruce for remembering that a friend of his used that. I was actually surprised that anybody got this at all. Thanks to Tony M0TDK who sent it in and said, do you think anybody would guess this? And I really wasn't sure. I think if I had to guess, it would definitely, I'd have said it was something like a wire strippers or something like that. But there we are. I've tried to show you with lots of images that Tony sent us exactly what it's used for. Well done to those of you who entered, and particularly said Bruce for getting it right. Well, what have we got to mystify you with this time for over Christmas then? Let's have a look. What on earth is this? Okay, I can't really give any clues here, can I? No, I better not.
I know what it looks like.
Yeah, well, anyway, do you know what that is? It's
Brum brum.
Oh yeah, brum brum. Oh,
Brum brum.
Oh, okay. Yeah. Well, it's kind of related to a hobby. That's all I could say, really. Kind of. That might help a little bit. Probably not, but anyway. This is the latest What on Earth. You've got a few weeks to get that to us. But if you think you know what that is, please send us an answer on an email to radio@dcpmicro.com. Do it as soon as you can. And we'll include it and we'll reveal what the answer is on the next NARC Live. Well, before we go to our guest tonight, just to let you know a bit what's happening on the club this week. As on Sunday, we've got the GB2RS News on GB3MB at 7 o'clock. On Monday at 7:30, the Monday Night Net on GB3MB as well. And at 8:30 on the 80-metre CW net on 3.543 megahertz. And then next Wednesday, the 14th of December, we've got our NARC Christmas dinner party at the Village Inn. Now, it's already been pre-booked, and I'm afraid it's too late now to book, but I know 66 of you are going. It's on between 7 and 10. We've booked a large private room for this. It's between 7 and 10 o'clock. You can arrive any time from that time. Get your own drinks when you get there, because your food is all taken care of, but drinks, you just get what you need from the bar. It's mainly a dinner and a social, and I've had a few people that asked me, are we doing any kind of entertainment or anything? Well, we didn't think that was appropriate. Speaking to most people we haven't had a dinner or anything like this now for a few years because of COVID, so we think that's most important. However, we will put a simple table quiz, if we can get it together in time for that. If you've got the odd question, by the way, you want us to include, if you've got a good one you want to do, then drop it on an email very quickly to us. We're going to be doing that in the next few days, Tammy and I. And also, though, we are going to try and raise some money for our charity of the year. The nominated NARC charity of this year is Cancer Research UK. And what we're going to do is what we usually do at the party we would have at the school up to a few years ago, and that is ask you to bring a simple, small, wrapped gift, which we'll put out on a table. We'll then sell raffle tickets in the evening. All of the money from the raffle will go to cancer research, and of course we'll raffle off the gifts that people have brought that evening for people. So the more gifts you can bring and the more raffle tickets we sell, the more presents that people will walk away with, and also the Cancer Research UK will do well from it too. So that's next Wednesday at the Village Inn between 7 and 10 o'clock. And our next talk, formal talk here on NARC Live, is on the 4th of January. And our next meeting at CNS is on the 11th of January. That's the Wednesday afterwards. However, we thought we would do a NARC Live between now and then, even without a formal speaker, because we used to, in COVID times when we were all locked up and couldn't go anywhere, we used to do sort of social, informal ones. And we thought we'd do one of those, maybe. What about an unboxing, a sort of Christmas unboxing? So if you've got something really nice for Christmas, we're not asking you to leave it until our programme, but if you've got something interesting and nice for Christmas, whether it's radio related or not, then maybe you could bring that along to the party, and we'll send a Zoom link, and it'd be nice to see everybody online, won't it? It'd be a while since we've done that. So that will be between now and the new year, when we have the NARC meetings start again.
Can't remember how we do that now.
It's a while. So we have not done that for a while. It must be sort of March time, I think, early this year, mustn't it? Because we started a meeting at the school from about April time. Anyway, that's it. Just to remind you to send your stories and your pictures and everything to us. Also, we've got this card, which we're always happy to send to anybody. Just drop us a line with the name and address. We try and get them to before Christmas. If they're in this country, we certainly should be able to. We'll add your name to ours and send it to radio@dcpmicro.com, and we will be very happy to send this NARC card to anybody that you wish. So now it's time for our main event, and tonight we welcome a special guest who's coming all the way from Colorado in the US. Rob, AD0IU, great call sign as well, works for NOAA Space Weather Prediction Center. So it's really lovely to welcome you, Rob, to NARC Live.
Well, thank you. It's great to be here, and I appreciate the invite.
Yeah, well, it's really good to see you. I mean, I've got to just ask you, Colorado, I've been to quite a few places in the States, but not Colorado. So what's the temperature like there now for you in Colorado?
Right now, we're probably sitting in the 40s Fahrenheit. So let's see.
So that's quite 15, low, isn't it? That's sort of getting
somewhere
in the
around, yeah, somewhere around 10, 15.
Yeah. Okay, well, I just wondered, because we're over here, we're sort of suffering a little bit because we've had a really, really good hot summer. I don't know if you've heard that in Europe. You probably do, that's your job. But now we're really feeling the cold, and we're about to get snow, I believe, in this particular part of the country as well, Norfolk, just overnight tonight. So that's why I ask. Anyway, you're going to tell us about space weather tonight. We're looking forward to that. And to everybody at home now, as usual, if you've got any questions or suggestions or anything that you would like to put to Rob, then put them to him during his talk, and we'll read them to him straight afterwards and bring them to you then. But now, over to you, Rob.
Okay. Thanks, David. All right. Well, as I said, I'm Rob Steenberg. I'm coming to you from the Space Weather Prediction Center in Boulder, Colorado, where we've been located probably since the mid-1960s. It's a beautiful day outside. I'm here to tell you about space weather and why, as an amateur radio operator, you might be interested in it. So, just some acknowledgments right up front. Some of the information that you'll see came courtesy of some of my colleagues, Patricia Doherty, who recently passed from Boston University, and then my colleagues here at SWPC, Mihail Kudrescu and George Millward, as well as Chris Balch, all provided information for this briefing. And then some of the historical information actually came from a professor right up the road at the the University of Colorado at Boulder, named Dolores Knipp. So what I'll talk about today, I'll give you an overview of the phenomena and impacts of space weather. We'll look at the events from the last solar cycle in September of 2017, which is really about as exciting as it got in the last solar cycle. We'll talk a little bit about an event that happened in July of 2012 that actually didn't affect Earth, but had it affected Earth, it would have been a fairly significant event. And then finally, because we're all amateur radio operators, there's some tips for radio amateurs, then we'll wrap it up. So I'll start with a little historic introduction and why space weather gained some of the notoriety and interest that it did, particularly in certain sectors. In this case, it's the defense sector, but in the 1967, so we're in the midst of the Cold War, and there was a huge sunspot group on the sun in the northern hemisphere, and you can see some pictures in the lower left there of that taken with a solar telescope. And that region would go on to produce a solar radio burst in conjunction with a flare. And that radio burst happened to occur on the frequencies used by the early warning radar in North America. And so that radar was wiped out temporarily by this event. Well, back in the day, doctrine said that that would be the first step prior to a intercontinental ballistic missile attack. So, of course, the folks in Cheyenne Mountain down the road from here in NORAD took this very seriously. And suddenly there was a lot of attention focused on this. Fortunately, though, there was an individual there who was a meteorologist who also was familiar with the sun and its activity, and mentioned that, hey, before we start inching towards any irreversible outcomes here, let's take a step back and make sure we know what we're dealing with. But by that time, they'd already scrambled the Strategic Air Command crews out to the bombers, B-52s. So they were getting ready, they're spooling up engines ready to go for a counterstrike. Now, fortunately, it did come about shortly afterwards that they realized they were dealing with a solar event and not an attack. So they were able to turn this whole machine off early before the planes took off. And that was important because this flare had trashed the ionosphere so much that it would have been difficult to recall those aircraft had they launched. And thus began the military's interest in space weather. And this, I mentioned this partly because I came out of the United States Air Force, and that's where I got my introduction to this whole phenomena, or this whole group of phenomena and its potential impacts. So there's a little bit of background. There's some other stories too. I've put a link at the bottom of this. If you'd like to read more, it's a pretty interesting story. Okay, so what about the sun gives us space weather? Well, it's got three ingredients: magnetism, convection, and differential rotation. So the magnetic fields are generated in the solar interior, and then convection brings them up through the solar surface. Following that, the differential rotation, it rotates faster at the equator than it does at the poles, and that differential rotation will twist up these magnetic fields. And, it's just similar to twisting up a rubber band. If you twist it enough, it's going to break. But the difference is with the magnetic field, they'll reconnect. And it's in that violence of breaking and reconnection of magnetic fields that you generate solar flares. When these magnetic fields come up through the solar surface, they form sunspots. And what you're looking at in that top time series in the orange, that's just the evolution of a sunspot group as it grew on the sun over the course of days. And below are the magnetic fields. Now, a general rule of thumb, that we use in the space weather forecasting business is the bigger it is and the uglier it is, particularly the magnetic fields, the more intertwined and complex they are, the greater the likelihood of a large solar event, large X-ray flare, or an eruption of plasma from the sun. I mentioned the rotation. The sun rotates every 27 days. It does a complete rotation on average. So you'll see sunspot groups that can go off the right-hand side of the sun as you're looking at it, which we call the west limb, and they'll come back and reappear a couple weeks later for the spots that are large and persistent. So here's an update on the solar cycle. You can see this plot runs from 2008 all the way through most of 2022, and you can see we're definitely climbing. We're kind of bouncing around for the monthly sunspot number. You know, we're coming up, bumping up against 100, so we still got a ways to go here. But it has been nice as a radio operator watching that thing climb. Additionally, we've seen geomagnetic activity increase, and you can see how the red line here indicates the AA index, which is one of the many geomagnetic indices out there, but it shows an increase in activity as well. And you can see this one goes back all the way to the mid-1800s, so you can get an idea. And if you look at the sunspot number for those who might have been around in the cycle that began around 1956, peaked shortly afterwards, that was a very spectacular cycle. And I've met radio amateurs at different talks I've given who were alive for that, and it was just a remarkable world to live in at that time. Okay, and then here's geomagnetic storm occurrences for the last solar cycle and the beginning of this one. And so we have a scale that runs from 1 to 5 for the intensity of geomagnetic storms, 1 being minor geomagnetic storming and 5 on the other end is extreme. And you can see here we had a few G4 or severe events, but not any of the extreme G5 events, either in the last solar cycle or so far in this solar cycle. So that's been interesting. I've got some statistics later too, if we have time, we can look at and see. But solar cycle 23 was the last one where we saw extreme levels of geomagnetic storming. So G is one of the big three. I like to call them the big three. R, S, and G. R for radio blackouts, S for space radiation storms, and G for geomagnetic storms. So the radio blackouts are caused by the solar flares I described earlier, associated with the large sunspot regions. You can see a picture of that in the upper right-hand corner. In extreme ultraviolet, you can see an X-ray flare going off in the southern hemisphere. That's usually the first of 3 phenomena that we see. In conjunction with that, you can get a violent eruption of plasma. And in the process, it can accelerate particles. And what you're seeing in the lower right with the S is the space radiation event. Those white specks you see are actually charged particles, protons and heavy ions that are hitting the charge couple detector on the spacecraft. So it's actually hitting the thing that gives us the imagery. This particular image is taken from a spacecraft called SOHO. It's called a coronagraph, and that disk you see in the center is held in place by that black arm that extends to the, I guess, the southwest. You want to look at it that way, to the lower left. In there, that white circle represents the solar diameter. And that disk is called an occulting disk, and it blocks out the brightest part of the sun so we can see the solar atmosphere around it, the sun's corona. And a similar image is in the lower left. In red, that's a different field of view, but that's showing you the eruption of plasma from the sun that would be heading towards Earth. This was a famous event in 2003 called the Halloween storms. It was a series of events, actually, but this was a relatively large flare that occurred. Each of these phenomena, the radio blackouts, the radiation storms, and the geomagnetic storms, like I mentioned, they all fall on a scale from 1 to 5, with 1 being minor, 5 being the most extreme. So here's a conception, courtesy of NASA, of how these events occur. You've got a large region on the sun in the upper left there. That active region, full of sunspots, can have that breaking and reconnection of magnetic fields, can be violent enough to eject plasma, billions of tons of material, moving at millions of miles an hour. We measure all this stuff in kilometers per second here at SWPC, but that comes off the sun, and it can get here in as little as 17 hours or as much as 3 or 4 days, depending on how fast it's moving. Moves through interplanetary space. These happen all the time. Most of the time, they're not aimed at Earth. Sometimes they come towards Earth. They bring with them their own magnetic field. When they interact with Earth's magnetic field, you get, again, breaking and reconnection, but this time of magnetic field lines around Earth, which accelerate particles towards the poles and into our atmosphere, giving us the aurora. So that sequence of events, you start with an X-ray flare. At that point, we'll put out an alert that says, hey, we have observed X-ray flux above a certain level, and we do that for each successive threshold. These thresholds matter to different customers, primarily ones concerned with HF radio communication. There can be radio bursts, as I mentioned earlier, that episode in 1967. We've had more recent episodes where they've interfered with aircraft tracking radar and where they've interfered with GNSS, global positioning systems. Energetic particles can follow. Those can get here to Earth in minutes to hours. We'll put out a warning if we have enough lead time, and that becomes important to folks who operate spacecraft, satellites. It becomes important to astronauts on the International Space Station. And now that we're moving beyond Earth orbit, again, in our efforts to get back to the moon, that will be of critical importance to those folks because they will not have the protection of Earth's magnetosphere that we enjoy and that the astronauts on the space station benefit from. And then finally, the solar plasma, the coronal mass ejection, or CME for short. Like I said, that can get here in hours to days. If we've got enough time, we can put out a watch, which alerts particularly customers like the power grid that this geomagnetic storm is anticipated, and they can take certain actions to mitigate the impacts on the power distribution system. Once it arrives about 1 million miles from Earth, it'll pass a satellite there, and it's just like a buoy out in space, and it gives us our first glimpse of what the magnetic field looks like and how it's going to interact with Earth's magnetic field. And then from there, we'll put out alerts as those thresholds are crossed. You can find the NOAA scales at that website above, and we've got another URL that's might be easier to remember. It's www.spaceweather, all one word, .gov. That'll also take you to our websites, and it's easier for people to remember sometimes. But we've got there the NOAA scales, and this breaks down the different phenomena, the blackouts, the radiation storms, and the geomagnetic storms. Gives you the levels, gives you the nomenclature associated with them, the impacts to different systems, the physical measure that we use to quantify those, and then the the frequency with which they occur during a solar cycle. So these are all pretty handy. Keep in mind, these were developed about 22 years ago now. Technology has changed. Some of the things that were impacts back when these were created aren't impacts anymore because we've figured out how to engineer around them. In other cases, new technologies are out there that may be affected. So we're in the process of examining these and looking at revisions to them. Since I started working at the Space Weather Prediction Center, we've brought 16 different numerical models on board, which is just a revolution in space weather forecasting. Because when I got here, we had about 2 or 3. And these run the gamut from empirical models all the way to full physics-based models. That one in the upper left is what we use to estimate the arrival time of the coronal mass ejections. When those come off the sun, we gather information from those coronagraph images you saw earlier. We parameterize those CMEs and put them into this model, and then we get an estimate back of when those arrive. Our error bars used to be about 24 hours either side. Now, for the clear-cut cases, we've got those down to about plus or minus 7 hours either side. So we've made huge strides there. Other things we're doing is modeling the geospace environments. The picture in the upper right and the lower left, both are images from that model. In the upper right, showing the magnetic field structure during a storm, and in the lower left, that's just showing you cut planes through Earth, looking at the Earth's magnetosphere and the bow shock and how that changes as these storms move by. And then finally, the geoelectric field map shown in the lower right is one of our newest products. About 10 years ago, the power grid reached out to us and said, hey, you give us a geomagnetic storm notification, G1 or G3 or so on, but that doesn't really tell the same story for somebody in Detroit, Michigan, or along the northern tier of the United States versus somebody in Texas or Florida. It's different because the ground conductivity is different. So we worked with the Geological Survey here to take models of the Earth conductivity and meld those with models of the geomagnetic field and those changes to give us mappings that then can be used by power companies to estimate the impact on their particular power grid. These are just a quick reference chart for the phenomena and the impacts. The radio blackouts cause interference to high-frequency communications on the sunlit side of the Earth. You can also have radio bursts across any range of frequencies that can interfere with things like radar or GPS, or even the frequencies that we use. The radiation storms can cause an impact in the polar regions called D region absorption, where the particles bury themselves in the D region of the ionosphere, significantly rev up the ionization there, and as a consequence, there's a lot of absorption. And people who rely on HF over the poles, including the aviation community, are impacted by this. And it can be to the extent that they won't fly up there and they'll not do the cross-polar routes, which costs them a lot of money in fuel. And then finally, geomagnetic storm. Of course, that makes the bands noisy. Post-storm, you can get depressions in the maximum usable frequency. So you can get these areas wandering around the globe of very, very low maximum usable frequency, and that can have an impact. We get the information out here at SWPC a variety of ways. We do so via phone calls to core partners, critical stakeholders like NASA, the Department of Defense, the Federal Emergency Management Agency here. we make phone calls to them, and we collaborate with those folks in case of NASA and the Department of Defense on a daily basis to make sure we're all working on the same page. Our product subscription service, it's no cost. You can sign up and get emails when these alerts, watches, and warnings go out. The website, as I mentioned earlier, spaceweather.gov, it contains all sorts of information. We have a radio operator dashboard that may be of interest to folks. We put things out on social media, on Twitter, and we were doing Facebook, but then it broke for a while. We think we might have it back, so we're working on that. And then traditional media, of course, contacts us as well. Okay, let's take a look at September of 2017. So in the summer, things were generally uneventful. What you see here are time series plots of information from one of our geostationary satellites, GOES 15. This is a weather satellite, but it's also got instruments on it to measure the space weather environment. So you can see there weren't a lot of huge X-ray events. The X-ray flares run from C, common level flares, M for moderate, and X for the most extreme. And you can see, so we had some C and M flares around July. Things got quiet for a while. Then we had an outage, and we were using data from another satellite. But then when September rolled in, notice all the X flares we're starting to see there. The number of sunspots increased correspondingly, and also the particles at geosynchronous orbit, the protons and electrons. You see a big proton event towards the far right side of that graph. Cosmic ray flux also was impacted. We measure those with neutron monitors. And then the magnetometer aboard the spacecraft also registered the arrival of those CMEs, and you can see those large fluctuations there. The culprit behind a lot of this was active region number 12673. You can see the red arrow pointing to the magnetic field there, Earth for scale alongside it. And then in the image at the top, that's just a white light continuum of that sunspot region. But that was the culprit. You can see we had good X flares around the 6th, about midday on the 6th. And then we had another set of events midway on the 10th, between the 10th and 11th. So a couple good X flares. There were some other smaller X flares in there too, but those are the big ones. And you can see the impact on the protons. We've got proton events showing up on the 6th fairly rapidly, and then some more bumps along the way, and then a really nice, well-defined one, and that was a very rapid onset event on the 10th. You can see the CME arrival between the 7th and the 9th, coming in on the 8th. You can see the huge fluctuations there. So that was a pretty exciting period of time, and I'll show you the impacts here in a sec. This is where we were in the solar cycle. So look at how far down the solar cycle we come. We're almost at the end. You know, we're almost bottoming out. We bottomed out around 2020. So we weren't at the solar peak, but the most activity and the most impressive stuff of that solar cycle actually happened on the far downslope side of that. And that's not unusual. So I like to remind people that, you know, just because we're out of solar max and entering solar min doesn't mean we're out of the woods. These things can still happen. We issued a lot of watches, warnings, and alerts. That's what you're seeing on the right. That's just a time series plot of all the different types of products that we issued. We had 123 of those, which was 5 more than we issued the entire previous month. We did that all in 1 week. So it was pretty spectacular. And this, keep in mind, this again was for a relatively mediocre solar cycle. The flares on September 6th, the largest was an X9.3. That was the largest we'd seen in 12 years, since 2005. There were some X flares that preceded and followed it as well. But you can see the satellite image there capturing that flare from the region. This was the impact on the ionosphere. We have a product called the D-region absorption product. You can see where the solar subpoint was located around western coast of Africa when this flare went off. So that big round blob, that's the impact of the solar flare. The stuff around the poles that you see, the red area in the north and south, that's from the protons, the energetic protons that happen. You can see in the blue box in the lower right an estimated recovery time of about 4 hours for the protons, which I think, given my experience, is very optimistic. Those things can last for days. In the mid and low latitudes, looks like a couple hours after the X flare. So the X flare, the flares themselves, they can last from minutes to a couple hours. The proton event impacts at the poles can last much longer. If you're familiar with the WSPR network, Weak Signal Propagation Reporter, I gathered data from that around the globe, not just the sunlit side of the Earth, but I gathered all the reports I could for that time period. And you can see the impacts. I looked at 40, 30, and 20 meters for both the X2 and the X9 flare. So you can see the X2 flare happened. We were recovering. Then things were starting to ramp up again. And then we got hit with the X9. And this, the number of connections, that's just the number of WSPR reports for two stations having a link. And you can see how those dropped, even considering that I was looking at the entire globe. That was still a huge bite out of the activity. But what's interesting, and what I'll highlight later too, is if you look at 20 meters, look at the trend afterwards. This kind of stinks if you're operating when this happens, but there's a payoff later on because you've got all that ionization now. So it kind of jazzes things up and can permit even much better conditions afterwards. So there's a penalty right up front, but there's a payoff down the road. Unfortunately, this happened to occur during what we run in the United States, a hurricane watch net, because we had 3 storms in the Gulf and the Caribbean. And I reached out to the amateur radio operator that relays traffic to and from the islands. And this was a quote from him that, this is a very bad time for this to be happening. Our Federal Emergency Management Agency runs, this was a single sideband net. Our FEMA folks run a variety of communication methods, and they are not restricted in power like we are. So they were still able to make contact, particularly using digital modes during these events. There was a radio burst on September 6th. This was reported by an Air Force observatory in San Vito, Italy. It occurred near the GNSS frequencies, so Galileo, GPS, and so on. And you can see the impact here on GPS on 6 September. This came from monitoring at the Royal Observatory of Belgium. And you can see particularly on, there's 2 channels they were monitoring on L2, which is the lower power channel. You can see it took quite a hit after 12Z and then again around 13. So forecasting the arrival of geomagnetic storms, typically when we have an event of this magnitude, we're going to be looking for a coronal mass ejection. We did indeed have one. So what we try and do is, like I said earlier, parameterize it. We get things like the speed, the direction, and the angular width of the cloud of plasma. And then we try to insert that into a numerical model, estimate the arrival time. That's what you see in the upper right. In the lower left is the monitoring out about 1 million miles from Earth, and you can see the arrival in that top time series plot, the red and white lines, where that red line dips way down. That's the Z component of the magnetic field, and that's really the key indicator that we look for when we're determining how much of an impact this is going to have on Earth's magnetosphere. So the further south that is, and the longer it stays that way, the worse the storm's going to be. You can also see the solar wind speed jumped up from 400 to about 600 kilometers per second. We have seen storms that go over 1,000 kilometers per second. And we've also seen storms where the Z component of the magnetic field has dipped below -40. So this was by no means a humongous storm, but it was significant. Finally, in the lower right, that's just ground magnetometer data showing you the disruption as this thing evolved. These are some more information about the CME and our forecast. The 3-day forecast that we issue that twice a day at 00, 0, and 1230Z. Down in there, you can see the G levels referenced in parentheses there. So we were expecting about a G3 storm with this. What we ended up with, though, was a little bit more. So on the KP scale on the right side there, those red lines, what they're doing is showing you the KP of 8, which maps to a G4 or a severe geomagnetic storm. And so we had each of those red lines represents a 3-hour period. So we had about 9 hours of G4 conditions spread out across the 8th of September. On the right side, or on the left side, you can see the different impacts at the Discovery spacecraft. That's another one parked about 1 million miles from Earth, and you can see the big upset there on the 7th going into the 8th as this thing really arrived. You see another one there earlier on the 7th, an initial disruption, but then you get a really big chunk of it there on the 8th. Again, it's showing changes in density as well as the speed and temperature changes that accompanied the arrival of that CME. I mentioned that the maximum usable frequency can be depressed in the wake of these geomagnetic storms. This is just a little description of what the maximum usable frequency is. We calculate this for a 3,000 kilometer path. And that's just how we get that data, or how we arrive at that maximum usable frequency value. This is important, and we calculate this for aviation interests primarily right now because we provide support to the International Civil Aviation Organization as one of 4 centers around the world that do this on a bi-weekly basis. So there's a lot going on up in the ionosphere when these geomagnetic storms happen. Typically, we divide it up into a positive and negative phase. There's a lot of detail here, but basically the short version is interplay between chemistry and atmospheric dynamics results in a situation where you're not going to have the same ionosphere that you started with when the geomagnetic storm is over. And it takes a while for it to recover. So you can see these impacts up to 3 days after the storm, and they can persist for a week. In this case, what I did here, again, I looked at the number of whisper spots, and I combined that with another type of magnetic index called the DST, or Disturbance Storm Time Index. The more negative that DST index is, the stronger the storm. You can see DST drops to around -80. In the number of whisper spots, the departure from the median, it dips, to about half of what you normally see, and that was on September 9th in the wake of that storm on the 8th. And then you can see another impact later on, not quite as severe, around the 29th. Again, this is another one. This is from 2015, so we're going back in time a little bit now, but you can see here the DST dropped to minus 140. And again, you had a significant bite out of contacts there. It also impacts GNSS, so that bite you see out of the southeastern U.S. around Florida and into Georgia and Alabama, that was a consequence of this geomagnetic storm and flare activity. You saw it also over in Europe. In this case, you saw it in the north, and that's on the 8th. In the middle there, you can see how some of that degradation has occurred in the availability of the ground-based augmentation system. In 2012, I was working a night shift, and we had a region 1520. Now, it was not in that position when this occurred. It had already rotated around, so it takes about a couple weeks to get across the Earth-facing side of the sun. It had rotated off the west limb or off the right side, but it was in a prime position when the flare occurred and this coronal mass ejection occurred to interact with one of NASA's satellites called the Stereo A. There were two, Stereo A and B. Only one of them is still communicating with us here on Earth. But that storm was massive, and it was equivalent to another storm that we'd had back in 2000. And you can see there we did get up to the G5 or KP of 9 for 9 hours straight. And then it, only backed off to an 8. So that was pretty significant. Dan Baker, who is a scientist who runs the Laboratory for Atmospheric and Space Physics at the University of Colorado, said if we'd hit, or if that had hit Earth, we'd still be picking up the pieces. He said that a couple of years down the road. And he was saying, this would have had a significant impact on the grid, for instance. Best case during one of these storms, it causes some instability. Worst case, absolute worst case, it can damage equipment. And that equipment takes time and to replace. And the lead times for that stuff are not trivial. And this is another event. This is, let's see, this is 2017. This was a far side event, so this was on the opposite side, facing away from Earth. Another large event, but I don't have data. I don't think. Oh, I do have some data for it. Yeah, and you can see there, BZ went below minus 40. It stayed that way for quite a while. So that would have been another big event. So we got lucky in the last solar cycle. We got missed by two potentially damaging events. All right, so now, what do you do with all this information? Well, here's some tips for radio amateurs. This came from a gentleman, NA5N, in the QRP Amateur Radio Club International. I was a big QRP aficionado when I was living down in Houston. And so I got really hooked into this, and he'd put together some good notes on this. So if you have a flare, and I mentioned this earlier, you'll have a HF blackout, generally an hour, maybe 2 for a really big one. But then you're going to have a jazzed up ENF layer for improved reflectivity, higher maximum usable frequency, so you can exploit those benefits. That second box has much of the same thing, and the frequency is typically below 10 megahertz. You're not going to see a lot of impact. You can use the K index from WWV because that's updated every 3 hours. You can get it from our website too to get the hack on the current geomagnetic conditions. The A index is what happened yesterday. So for the most up-to-date stuff, you want to use the K index. The magnetic field can get quiet following a strong geomagnetic storm for a while. That's nice. You can work the low bands. Keep in mind, you're also potentially contending with a depression in the maximum usable frequency. And I always like to point this out, my final thought here. Don't let reports of flares or storms scare you. The things that I issue here in the Space Weather Forecast Office generally are global in nature. There's a lot of variety in the ionosphere. And so just because I put out an X-flare alert, or we're in the midst of a geomagnetic storm, shouldn't prevent you from getting on the air. Tune around. Sometimes you'll be surprised because there are regional and local effects that can more than make up for some of the impacts you see. Other times it's just going to be a disaster, and you got to go find something else to do, like build a radio or do some maintenance or whatever. One other thing I want to point out, recently, and when I say recently, I mean in the past 5 to 10 years, the Met Office has spun up their own space weather effort there. I've reached out to one of my colleagues there at the Met Office too. I haven't heard back from her, but I wanted to see if they had a point of contact for the radio community and space weather. I'm kind of the default here at SWPC because I have my I'm one of the few with my amateur radio license, so I get most things amateur radio get referred my way. But they've been doing this for a while. They've done some really amazing things. They weren't hampered by 50 years of history, so they were able to do some pretty innovative things. So I'd encourage you to check out their website as well. That's our website, and where you can find some of the information, the flux number. Everybody likes the 10 centimeter flux. You'll find that on the top page, on the front page there in the upper right-hand corner, as well as the space weather conditions for the RS and G scales. So if those scales are active, if we've got something going on, those change color and they'll tell you what's going on in there. Other things you can see on the radio communications dashboard include that D region absorption product I mentioned, the KP index. In the lower left-hand corner is the auroral forecast from our Ovation model. If you're interested in the aurora, either working it from an amateur radio perspective or just seeing it from a human perspective. And then finally on the lower right is just one of our images from the GOES spacecraft that people use to keep track of what's going on. We've got a new model out there, and you can find this on our webpage. This is the WAM IPE model. So now we're doing maximum usable frequency forecasts. This is new territory for us. So check it out. That can be of use to you guys. And we've been kind of integrating that into some of the support we provide to the aviation community. But this has really been a tremendous effort, and it finally came to full operations between August of last year and this year. If you like flux forecasts, I included a link to a website there where you can get a right now, the forecasts we do are primarily empirical. This is an attempt to do a model forecast of F10. And so I've seen some decent success with this. So it might be a useful addition to your bookmarks. And that brings me to the end. This is a Calvin and Hobbes cartoon, which was popular here in the US. For several years, and then along the bottom there you can see just different images from the Space Weather Prediction Center. If you ever find yourself on this side of the Atlantic, we do offer public tours, typically on Tuesdays, or you can reach out to me directly. I'd be happy to show anyone around when you come here, keeping in mind we have certain restrictions because of COVID. So we'll work around those. Right now, we're in a particularly high period of COVID transmission, so it's like a mausoleum around here. It's very quiet. And there's some pictures of my station from 1980 when I started, all the way up through my QRP phase in 2014. Lots of QRP radios, and then finally, that's what it looks like today. So with that, I will turn it back to David.
Thank you very much, Rob. Nice to see your shack as well at the end. We've got a few questions already, and some comments, but I'd also like to encourage anybody at home now to make any comments or questions that they can. I know one of the people watching on BATC, Jim G3YLA, was involved with weather forecasting all of his life and is a very active radio amateur too, so he might be able to provide a contact maybe with the Met Office, although I wouldn't expect him to put it here, but maybe I can put you two in touch if he has any ideas of who to speak to at the Met Office.
Okay.
He's got a license, that
and
might be good.
If I get feedback too, I'll send it your way so you can share it.
Yes, sure, I will do. Thank you. So first up, Tom Miller says, 27 days rotation, solar day. Is that returning to the same point facing the Earth or a full 360 degrees?
That's typically returning to the same point facing the Earth. So if you start at the solar meridian, about 27 days later, it'll be back at the solar meridian again.
Okay, thank you. Neil Bowers, he's got a longish email here, but I'll message rather. Around 1970, G3BGL, my physics teacher, built a receiver and decoder and got weather images from NOAA-1. I think these were the first images decoded in the UK before the professionals even. He used a CRT and the spot scanned a negative on the screen. This was focused onto photo paper in a dark room, and when developed, a positive image was produced. That sounds ingenious, doesn't it?
That's fantastic.
It's wonderful. You know, I had a really good science teacher myself who was very inspirational. I think maybe helped with my dad, along with my dad, helped set the course of what I was to do. And that sounds like Neil had a similar good physics teacher to sort of encourage him. I don't know if you, I mean, NOAA-1, I did get involved once in professional with making weather satellite receivers for NOAA, which were not geostationary. You know, that was the Meteosat, I think.
Yeah.
So that was probably around the late 80s, I think, something like that. So NOAA-1, I guess that predated that.
Yeah, I think so. I think that was 70s. I'm not even sure. I remember we had a scientist who worked here, as engineer actually, but he worked with a lot of the early spacecraft, including the earliest GOES spacecraft. And I'd go in his office and he'd have code up on his screen, but it would just be binary. And he could point, he'd be like, I think the problem is right there. That should be a 0, not a 1. And it was just amazing. He was absolutely incredible.
There are some incredible teachers like that on there. I'm sure there still are as well. Very inspirational. Got a question now from Les, G0DFC, I think from memory, your call sign Les. Where are we? I've just lost that question now. Sorry about this. Here we are. Do we see anything unusual with regards to climate change?
That is an area that, there's overlap, but I spend all my time pretty much focused on space and pretty much the 0 to 3 day forecasts. I do have colleagues in the building here who deal specifically with that. What I can say is they've looked at the coupling, the Earth-Sun coupling and different cycles and things. And there's influence, but it's not of the magnitude of some of the other factors. But that's probably as much as I can say about that with any certainty.
Okay, thank you, Rob. Tom GAXQD, I think, also from memory, Reles's question, the last one that was, how has the distance to the sun changed in the last 50 years? Are we closer or further away from the sun?
I don't know. Off the top of my head, I couldn't tell you. That's another one of those longer term things that I would have to go dig into. So that's I don't have an answer for that.
Okay, that's all right. That's fine. We're definitely not here to catch you out, but it's better to be honest, isn't it, than not? Well, maybe someone else knows.
And I'll tell you what, for the purposes of my forecast, it hasn't changed.
Okay.
At least in the 10 years I've been here. I mean, it may be, but it's not enough to matter in the work that I do.
Yeah, well, one thing I was going to ask you, personal question really, from my point of view, you mentioned radio blackout. I mean, I know that with the propagation forecast, it obviously does affect different bands, but when you talk about radio blackout, that's pretty stark. Does that apply to pretty much all bands, do you feel?
No, no. And that's one of the things I mentioned when we put these scales together 22 years ago. That was the wording that they chose, but it's kind of a misnomer, and it's particularly so now that we have the different types of communication modes beyond single sideband and radio teletype. Some of the weak signal digital modes and things. So there's much more robust communication, and so the radio blackout terminology is kind of a misnomer, and that's one of the things that we're looking at trying to revise when we while we're re-looking the NOAA scales. And that was pointed out to us, that was pointed out by our colleagues at FEMA, because they're like, it wasn't a blackout for us. We still did what we needed to do.
Okay, thank you, Rob. Steve G0KYA says, I prepare the RSGB's weekly HF propagation forecast. I find the 28-day NOAA predictions aren't terribly accurate. Are there any other SFI/K index predictions available?
Yes. In fact, that was one of the slides I showed. If you check out that website, and in fact, let's see, I don't think I'm still presenting, but it is gong.nso.edu.
Yeah, we can show that.
That's the one. That's the one.
So
if you check that out.
So we'll just read that out again, because it's quite small and quite difficult for me, and I'm watching on a direct monitor. So it's gong.nso.edu. And do we need the rest of it, do you think, for that?
Yeah, it might as well. It's,
okay, so I'll read it out to you. This is for Steve or anybody else interested. So gong.nso.edu/ADAPT/SIFT/F10_forecast FORECAST.txt. I hope that helps, but you'll be able to watch this back anyway, Steve, or anybody else, and replay that. So thank you very much for answering that as well, Rob. And one other thing, I think, because I think that's almost all of our questions, I think, that we've had. It seems to me that as a radio amateur, and you say there aren't too many of you there with a license, but it's been really important and very, very, almost the two combined, your hobby and your work. It must be really useful to be able to understand that side of the, of your work, being a radio ham yourself.
Oh yeah, absolutely. And it's just so funny too, because, if you looked at the stations I had up there, I had one in 1980, and when I went in the Air Force, I went in as a meteorologist. Actually, my first duty station was at RF Mildenhall, so I have links to that side of the world, and it was a fantastic time. I was only there for 2 years, but it was amazing. But during the time I was in the Air Force for those 23 years, most of that time I was not on HF. I did keep my VHF radios, but putting up HF antennas and things on the bases where I lived was not trivial. So, and I had other things going on, raising a family and stuff. So I got back into it in 2007, and it was funny because that's the same time I came back into the space weather career field. So it was kind of remarkable, the overlap, and I quickly found out how much I'd missed, the first time around. Back when I was 15 years old and got my license, I wasn't thinking about the ionosphere as much as I do today.
And of course, you can find out so much more there. I mean, possibly, I don't want to make any presumptions about your age, but if you're similar to me, then there wasn't the internet and things when we were 14, 15. So there was, you could only look things up in encyclopedias and libraries and things like that. Got a couple of actually other comments for you, so we're not quite ready to say goodbye. Steve, by the way, G0KY said cheers for that information. Tom Miller has said from good old Google, in short, he says, the sun is getting further away from the Earth over time. On average, this is Google saying this, Earth is about 93 million miles, which is 150 million kilometers from the sun, according to NASA. However, its orbit is not perfectly circular. It's slightly elliptical or oval shaped. So there varies, I guess, is what that's saying.
Yeah. Yes. And
finally, then, this I mentioned that we had a professional weather forecaster on our team. It was television weather forecaster for many years for the BBC and ITV as well, and is a very active radio amateur as well. So this is from Jim, G3YLA. He said, very interesting insight. Thank you, Rob. You spoke of improvements in forecasting arrival times, etc. What needs to improve to make these better? And there's a question mark after that. Measurement data or modelling or more satellites? And he said, P.S. used to work at Mildenhall as a meteorologist.
Oh, man, that's awesome. That's awesome. Yeah. Let's see. I would say yes to all of them. I need better observations. I need more satellites, and I need better modeling. I need all of it. Things that have been discussed. For instance, one of the things that's horrible right now, and that fills my dreams with terror, is I don't know what the magnetic field looks like in that coronal mass ejection when it comes off the sun. I have no idea. And there's been attempts in the research community to try and get a handle on that. Hasn't happened yet. So I can see this thing leave the sun. I can parameterize it. I can get an arrival time. But the strength estimate is very tenuous. It's definitely not an exact science at all. And I don't know anything about it until it gets about 1 million miles from Earth. And in terms of the speed with which these things move, that could be an hour, it could be 45 minutes or less. So that doesn't give me a lot of time to put my warnings out. I could get the watch out, but it doesn't give me a lot of time to put the warnings out. And the watch is kind of a stab at what we think our best estimate of the intensity is going to be. So, if I could, in Rob's perfect world, I'd have satellites maybe upstream, closer to the sun, between the sun and Earth, giving me updates along the way. The UK is working with the European Union to put up a spacecraft in a position off the Sun-Earth line to give us information about the CME as it travels out from the sun. And that a heliospheric imager on there would give me more information. So that could be another positive. And then finally, the numerical modeling has been remarkable. And what we're hoping for, the real goal of a lot of this is to get a sun to Earth coupled models. And we're dealing with so many different scales and phenomena in between here and there. Making that a reality is a real challenge, but it's something that we're moving towards, and we're doing that in the international community. So it's pretty spectacular. So yeah, I'll take whatever I can get.
So you do collaborate, do you, with many other parts of the world for data, for weather data? There's not many barriers between collaborating. There's not many not rivalry, shall we say, between different forecasters.
No, in general, no. Some nations are more apt to share data than others in certain circumstances because of national security interests. For instance, they don't necessarily want people to have a great handle on what their ionosphere looks like. So there's varying levels of cooperation across the globe. But in general, everybody recognizes the importance of it, the need for cooperation and collaboration, and to the extent that that we can as scientists, we do. And it's been just remarkable to watch the evolution across the globe of different space weather centers. Like I mentioned, the Met Office spun one up. There's a center in Belgium. Mexico spun one up. There's one in Canada, and so on. We're hosting a visitor from Australia right now, from their Bureau of Meteorology. And they've had a space weather interest for quite some time. So yeah, it's it's remarkable. There's generally good cooperation. Like I said, there are some things that I think people hang on to more tightly because of national security concerns, but in general, it's a very collaborative environment.
And is that just that collaboration? Is it just between professionals, or is there any place even for any of the amateur meteorologists to send data and share data with you?
There is, and there's an effort in the United States right now, and I don't know if it's kind of crossed borders yet, but in the United States, there's an effort called HAMSCI, HAMSCI, and it involves enlisting the help of radio amateurs as citizen scientists to collect and redistribute data about the ionosphere and also about the magnetic field. And so this is led by a gentleman named Dr. Nate Frizzell. He's at the University of Scranton in Pennsylvania. Unfortunately, I can't remember his call sign off the top of my head. It's a 2 call sign, N2 something, I believe. But anyhow, Nate has been leading an effort among a variety of amateur radio operators who, from just regular folks who aren't scientists, just with an interest in amateur radio, to people who are scientists and amateur radio operators. And together, they're working on building sensors and things and conducting experiments to gather information and share it. So yes, there is definitely a participatory aspect to this, and there are definitely opportunities. Yeah,
it sounds a fascinating aspect of amateur radio, and I'm sure a lot of people are interested. I should have mentioned as well that Jim G3RLA works with Steve G0KY as well, and does the VHF and up propagation forecast for the RSGB. So nice. They've both got a big interest in that. Finally, I'd just like to remind everybody at home, you gave a nice shortened or easier version of your URL to look at, which was www.spaceweather.gov. Spaceweather, all one word, .gov. I looked it up on my phone and checked, and that works lovely. So that's really good. Steve G0KY just came back and said a number of us in the UK are HAMSCI members already, so that's good. So the message is getting out there, and the collaboration between you. Rob, thank you. It's been fascinating to understand space weather. It obviously does affect our hobby as well, and the propagation forecasts and everything that goes with our hobby. And we really value your time to joining us tonight. So thanks very much to Rob, AD0IU, a wonderful call sign. Very different.
Oh, thank you so much. It was a pleasure, and please feel free to reach out. Anybody, my email address is on the first slide there. So if you've ever got any questions or anything, hit me up, because I love this stuff, and I'm fortunate enough to be doing radio and space weather, and it's just, I can't even ask for anything more.
It's clear it's a dream job for you. Many thanks, Rob, for joining us. And you've got a QRZ page as well, haven't you, by the way? And of course, people can contact you via that as well. Once again, thanks very much for joining us.
Okay, thank you. Take care.
Thank you, Rob. There we are. What an interesting subject, space weather. You know, and a way it does affect our hobby a great deal. Thank you very much to Rob for joining us. I know as well he's not officially working as well, so he's popped into the office to do that and meet this lady from Australia as well, but it was nice of him to give us this talk this evening. So just to go over what's happening this week at the club. So on Sunday we have the GB2RS News on GB3MB repeat as usual at 7 o'clock. On Monday at 7:30 the GB3 on GB3MB as well, the Monday Night Net. At 8:30 the 80 metre CW net on 3.543 megahertz. And then next Wednesday, the 14th of December, a week tonight, we have our Christmas party and dinner at the Village Inn between 7 and 10 p.m. And if you can, please bring a small wrapped gift, which we can use as a raffle prize for a raffle that evening, which all the proceeds will go to cancer research. And we hope to see you as well on another NARC Live with maybe an unboxing. So keep thinking about all those things that you get that are a bit unusual, maybe for Christmas time, and we'd love you to share them with us. And it'd be just nice to see everybody at work as well over the time. But that's about it. Keep in touch with your stories as usual to radio@dcpmicro.com. But until next time, from Tammy M0TC.
Bye-bye.
And from me, David G7URP. Goodbye.